Welcome to the lesson 25 class activities for college algebra. We're going to use the same steps that we did in the demo to sketch a graph of 1 over x squared. So the steps are now laid out here. What value is excluded from the domain of 1 over x squared? 0, right? X can't be 0 because 0 squared is 0. You'd have a 0 in the denominator. So arrow notation to describe the behavior of f of x near 0. So as x gets really close to 0, what happens to the y values? So as x approaches 0, you're going to put in something really small into the denominator, and 1 over something really small is going to be something really big. When you put that really small thing into the denominator, you're going to square it, which means it's always going to be positive. So for example, let's just do like 1 over 0.1 squared, right? This would be f of 0.1. So 0.1 squared is 0.001, which is 1,000. Sorry, 0.1 squared is 0.01. So this would be 1 over 0.01, which is 100. So you can see you're plugging in small things, getting out big things, and the big things you get out are always going to be positive because when you square something, positive or negative, it comes out positive. So as x approaches 0, g of x approaches infinity. And then for the end behavior, as x approaches infinity, so now we're putting not small things into the denominator, but really big things. And 1 over something really big is really, really small. So we're going to approach 0. And same thing, as x approaches negative infinity, you're also going to approach 0. It doesn't matter whether you're plugging in positives or negatives because you're squaring it. Okay, so equation of the horizontal asymptote, that would be y equals 0. Why does this keep jumping? Okay, do we have any x or y intercepts? Nope. You can't plug 0 in, so there's no y-intercept, and it can never equal 0, so there's no x-intercept. So to sketch a graph, let's see, I might do a couple of points, like if I plug in 1, I get 1, and if I plug in -1, I get 1. So I have 1, 1, and -1, 1. And I know that as x approaches infinity, my y values approach 0, negative infinity 2. And as x approaches 0, my y values approach infinity. So that's 1 over x squared. It most definitely looks like an even function, right? Even function or y-axis symmetry. Okay, now we've got a few examples where I want to sketch transformations of either 1 over x or 1 over x squared. Label the asymptotes and intercepts. So I want to graph h of x, which is 1 over x minus 5. So my domain is all x values except for 5, because if I put a 5 in here for x, I would get 0 in the denominator. So this would be the set of all x's such that x does not equal 5. And my parent function is 1 over x. And to describe the transformation, I would say, okay, well, it's with the x. It's under the fraction bar with the x. So it's a horizontal shift 5 to the right. Values excluded from the domain, 5. Equation of the vertical asymptote. So my vertical asymptote for 1 over x is the y-axis. So now it's going to be x equals 5. We move it 5 to the right. X and y intercepts. So there's no x intercepts because you can't set that thing equal to 0. It will never be 0. The only way a fraction can have a value of 0 is if the numerator is 0, and the numerator is always 1. So there's no x-intercepts, but the y-intercept I get by doing h of 0, which would be -1/5. So let's draw what I've got so far. My y-intercept is 0, -1/5, something like that. And I have a vertical asymptote at x equals 5. And then I know that it's going to have the same general look as 1 over x. So it's going to be something like this. And then this one like that, and then approaches the x-axis and approaches the asymptote. So behavior near the vertical asymptote, as x approaches 5 from the right, f of x goes to infinity, and as x approaches 5 from the left, f of x heads down to -infinity. And then end behavior, as x approaches positive or negative infinity, f of x approaches 0. Horizontal asymptote is the x-axis, which has the equation y equals 0. And that's it. All right, next one. I have 1 over x minus 2 squared minus 4. So my domain is all x values except anything that might make that denominator 0, which would be the x value of 2. Right, so the set of all x's such that x does not equal 2. My parent function here is 1 over x squared, because it's got the squared there. Okay, so to describe the parent function, I've changed the x. Instead of just 1 over x squared, it's 1 over x minus 2 squared. So that's a shift right 2 units, and then the minus 4, that's outside the function, so that's a shift down 4 units. So this is right 2, down 4. And before I even start trying to answer these questions, I can sketch this. I can just move my asymptotes. Instead of being the x and the y-axis, which were my asymptotes of 1 over x squared, remember 1 over x squared looks like this, very roughly like that. So instead of having asymptotes as the x and y axis, I'm going to move those asymptotes right 2 and down 4. And then I should be able to sketch my graph of what 1 over x squared looks like. And then you can answer the rest of the questions, right? So values excluded from the domain, that would be 2. Can't plug in a 2. Equation of the vertical asymptote. So this vertical pink line here is x equals 2. X and y intercepts. It does look like I have some x-intercepts and a y-intercept, right? So I might go about trying to find those. Y-intercepts you get by plugging in 0. So that would be 1/4 minus 4, which would be -3.75, which does look like it's in about the right spot, -3 point something. So my y-intercept is 0, -3.75. And then x-intercepts you get by setting the function equal to 0. So I have 1 over x minus 2 squared minus 4 equals 0. 1 over x minus 2 squared equals 4. So 1 equals 4 times x minus 2 squared. 1/4 is x minus 2 squared. Square root both sides, so I get plus or minus a half equals x minus 2. Add 2 to both sides. So x equals 2 plus a half is 2 1/2. 2 minus a half is 1 1/2. So my x-intercepts are 2.5, 0, and 1.5, 0, and that looks like pretty much exactly where the picture I drew crossed, 1.5 and 2.5. Behavior near the vertical asymptote. So as I approach my asymptote, my vertical asymptote of 2, as x approaches 2, from the left or the right, either way, as you get close to 2, the function values go up to infinity. And then end behavior, as x approaches positive or negative infinity, whether you go to the left or to the right, the y values approach the horizontal asymptote of -4. Equation of the horizontal asymptote, y equals -4. All right, one more. X over x squared plus 3x. Okay, so the domain would be all x values except for things that would make that denominator 0. So let's see, x squared plus 3x equals 0. So it looks like I can't have 0 or -3. Either of those x values would make my denominator 0. Parent function, it says factor the numerator and denominator and then reduce, right? So k of x is x over x squared plus 3x. Factor the denominator, and the x's cancel, and you get 1 over x plus 3, which means my parent function is 1 over x. Describe the transformation, that's left 3. Values excluded from the domain, again, 0 and -3. Okay, so my asymptote is at -3 because I'm moving left 3. Okay, so that vertical asymptote is x equals -3. X and y intercepts. So x-intercepts happen when the numerator is 0, x equals 0, but you can't plug 0 in. It's an excluded value. So there's no x-intercept. And then for a y-intercept, if you plug 0 in, you'd get 0 over 0, which is undefined, so there's none, right? You can't make it equal 0, and you can't plug 0 in. So 0, 0. So I can't plug 0 into the unfactored version, right? If I plug a 0 in here before I cancel, I would get 0 over 0. So you can't plug 0 in. But if I were to plug it into the reduced version, I would get -1/3. So 0, -1/3 is what's known as a hole in the graph. So I can't plug 0 in to find my y-intercept if I plug into my original function. Try to put a 0 in there for x, you get 0 over 0, it's undefined. But after you do your factoring and canceling and you have a reduced version, that reduced version of the function is identical to the original version of the function, except that I canceled some x's. So you can't plug, if you were to plug in a 0, that -1/3 is invalid. Okay, so we put an open circle there. And now I should be able to just draw the graph of 1 over x using my purple vertical asymptote and the x-axis as my horizontal asymptote. And my hole should do the trick here. Sorry, it's not -1/3, it's just 1/3. It should be 0, 1/3. There we go. Okay, so my behavior near the vertical asymptote, as x approaches -3 from the right, f of x gets really big. F of x heads up towards infinity. And as x approaches -3 from the left, f of x heads down to -infinity. My end behavior, as you head way out to the right and way out to the left, in both instances, the function's y values approach 0. So as x approaches plus or minus infinity, f of x approaches 0. Equation of the horizontal asymptote, that would be y equals 0, the x-axis. What happens when x equals 0? So like I just said, if you try to plug x equals 0 into the original, you cannot. You're not allowed to, because you get 0 over 0, which is undefined. But you could plug it into the reduced version of the function, and you'd get 1/3. But that's an invalid y value, because you're not actually plugging into the correct function. But if you could plug in here, you'd get 1/3. So you have to just leave that value out. And it's called a hole. We call that a hole in the graph.